Okay, I think we're gonna start. So I waited 5 or 6 minutes longer than normal. So even that people already joining, I think we could start. Yeah, again, welcome to the next step to the EclipseStore Advanced training, Advanced 1 to be precisely. I see some people that take part in the fundamentals training yesterday. And I always have to say the advanced training is recorded and you will get access to that training afterwards. Let me introduce myself a little bit. My name is Kuemmel. I'm Java developer for around 15 years now. Currently, I'm project manager of the MicroStream cluster development. And I'm also involved in some projects within the Allianz insurance company and also the Fraport German airport. Especially these are projects we are working with EclipseStore and yeah, I think that's the point on me. Sometimes I'm also a conference speaker and mostly I'm the trainer. That's why I'm here for today. So yeah, let's move on. This is the timetable. We start at 5 till 9. I left enough space for your questions. So the Advanced 1 training is always a good opportunity for you after you started maybe with EclipseStore and you created some smaller projects, whatever, you do some proof of concepts, whatever. And it's a good place for asking questions that appears during your proof of concept or something else. So that means I left enough space for your question. Feel free to answer the questions whenever you want. Type it in the chat or do it via microphone. That's okay for me. So we are not that much people. That should work, definitely. I always mention that the session is recorded, so you will get access afterwards, and you will also get access to all the code repositories of the demos we are working within that training. Let me just share directly the major links for now. So fire in the hole, a lot of links are incoming within the chat. And yeah, these are the basic URLs that you need to follow all the topics within the training. The links to all the GitHub repositories of EclipseStore, the documentation of EclipseStore itself, and a lot of training examples on my GitHub repository. And there is also a certificate at the end of the training. I would say 5 to 6 days after the trainings, or a week, I would say. You will be able to register on our cloud platform, and then you will see a certificate area on the left. So give me just a second, and I can show you this. Okay, it should look like this. After you register, you should see a screen look like this, and then you see certification on the left, and you should be able to click on that I and download the certificate at the end. You can print out or whatever. This is the way you get your certificate. But yeah, you have to wait a week after the training around. So that's important. I always have to upload the data to the cloud and make it available at the end. Okay, so let's see what I want to talk about, the topics for today. Like always, I will start with a warm-up project exercise, especially for those of you who attend the fundamentals training longer before. So just to summarize all the stuff regarding EclipseStore. So I would say for today, we could do that exercise together. So we create a small project, a small example project with all the stuff you need to know about EclipseStore. After that, we are talking about configuration in advanced. So unfortunately, this is the advanced trainings there are no red threads through specific topics that belongs together. We just jump from one topic to another and dig a little bit deeper in these topics. And that's why we have to talk about advanced configuration. That means what type of configurations do we have and when to use a specific one. We have to talk about exception handling. That's also important. Some stuff regarding gracefully shutdown. That's also important, especially when you use EclipseStore on Kubernetes, for example. Then this part could be a little bit helpful. The reason for that is we had a customer a few weeks ago, and he was in big trouble because he used EclipseStore within Kubernetes and tried to use some external functionality of Kubernetes to create backups and so on. And this is what you should not do at the end. Then I want to share with you configuration of an S3 bucket for the storage and also a Micronaut integration. I would say a lightweight Micronaut integration because it's not a training about Micronaut. At the end, it's a training about EclipseStore. And yeah, as always, I tried to keep it as simple as possible and understandable for you. After that, we have to talk about storing. For the guys who attend yesterday on the fundamental training, it's kind of like a repetition, I would say. We have to talk about eager and lazy storing and what does it mean. But then we have to talk about transactions and rollback stuff. How is this working? Another important topic is lazy loading. I also talked about that yesterday, but I want to dig deeper into lazy loading and how to use it and what the best practices of lazy loading. I think that's important. Then we have to talk about legacy type mapping in detail. That means what happened if class changes and so on, how to handle some changes within fields and renaming and stuff like that. So that's important. And last but not least, we have to talk about backups, how to create ones, how to configure them, how do they work, basically. And as I said, there is a lot of space for your question and answers. If there are no questions for today, I'm pretty sure we will finish the training at 8. As I said, I left enough space for your questions. Okay, so let's move on. So as I said, let's summarize EclipseStore a little bit. So for those of you who not attend to the fundamentals training, what is EclipseStore? EclipseStore is a Java framework, basically, and it consists of a from scratch invented object graph serialization. And it enables you to serialize data to the most known systems. Could be file system, AWS S3, Kafka, relational databases, DynamoDB, and so on, a lot and many more. And this, at the end, you will be able to serialize the data to the storage partially. That means we are able to change smaller parts within your object graph and only to update that changes directly on the binary part. That is the greatest thing on EclipseStore, I would say. And the point is, EclipseStore keeps most of the data in memory, except the lazy parts of the graph. That means there are some points where we are able to adjust which data is needed all the time in memory and which one could stay on the hard disk as long as it is needed. So that's an important point. There is no data mapping anymore. So we use the Java object graph as it is and as the same structure, on the binary part, I would say. So that no data mapping is needed anymore. That is also one reason why EclipseStore is that fast. And we just operate with pure Pojo classes, I would say. Just your normal, well-known Java objects. That's all we need within EclipseStore. Okay, so as I promised, I want to start with an exercise. If there are any questions so far, let me know. Just write down this to the chat and let me know if there is, if something is unclear or whatever. Not so far. So during the time, let me share, or during your questions, let me share the GitHub repository for the exercise. There is one question. Is there a way to interact with other languages than Java? On the framework side, I would say no, except the normal Java language, the normal Java languages like Kotlin or other stuff like this. But if you want to use EclipseStore within a non-pure Java ecosystem, I would say, then it is possible to create some microservices that provide data via REST. And that enables you to provide data also to other language microservices that use it, other languages. Just use REST endpoints at the end. But basically, for the framework, you have to deal with JVM languages. Hope that answers that a little bit. Okay, so back to the exercise. So just check out the project car exercise. And by the way, it doesn't matter what kind of IDE you use. Choose a Java IDE of your choice. The important thing is all these projects we are working on are Micronaut projects. So you have to enable the annotation processing of your IDE. That's important. But so far, just clone this project to your IDEs, and you will be able to code along with me at the end. You can start on the start exercise here branch if you want, and if you want to code along with me, just use the start exercise here branch. And the first step is just complete the following classes. So there are multiple classes already available within that project. So I talk about a DB class, a car controller class, a brand controller. There is these are the classes you have to complete. And of course you have to initialize the storage manager, and the storage manager should be initialized within the DB class. And we want to have a channel count by 2, and the storage target should be data. It's quite easy to set up that stuff. And yeah, I give you 5 minutes just to check out the project, to set up everything. I also jump back to my IDE. I already opened the project, so the car exercise. So this is the car exercise itself. It looks like this in my IDE. We do not need those screens. And as I said, there are some brand and car controller classes, also the domain classes. So let me just explain the structure a little bit. So there is a company, and that company consists of a name and a list of brands and a list of cars. And we have cars itself. A car consists of a model itself and a brand. And we have the brand domain, which has only one field, which is the name. Easy and simple, the data structure itself. As I said, the DB class is empty. And for those of you who said, okay, I tried to use the Micronaut implementation of EclipseStore and so on, this is not the topic of that training. I would say, as I explained, keep it simple. Just use the normal initialization methods of the storage manager. We use that in a static way. It's not the right way to do, but it's okay for that training, I would say. Okay, so for those of you who use Eclipse, I just want to mention that annotation processing thing. You will find it within the preferences on the Maven section. When you drop down the Maven section, you will see annotation processing. It is on experimental on my side. That's okay. That's totally enough. There is also a setting on IntelliJ. I knew that, but I don't know exactly where it is. So if someone could write it down shortly, where to find this within IntelliJ would be great. I'm not a really guy of IntelliJ. So, but I knew there is a setting like this also in IntelliJ. Just to ensure if the project is working properly, you could, here we are, you could directly jump into the application class here. And to start it, just click on Run As and Run As Java application. That is okay. Normally, you should not see that much output. The reason for that is that I have to do a Maven update at the end. Say okay, because I changed some parts a little bit. Okay, so if we now start this, it should look like this. You will see the Micronaut, and you should see startup completed, and you should see the URL to load or to call the controller classes later on. Okay, great. Thank you for posting that stuff for IntelliJ. Okay, so let's move on. Are you ready? So we can start? Yes. Okay, let's do it. So let's start. So, okay. Give me just a second. I have to open my classes also. Oh, come on. Here we are. Storage. Okay, here we are. Okay, so yeah, let's start on the DB class. Maybe the clean package should work to run it from the command line. No, sorry, not clean package. Just a second. I have to find the right Maven. So this should be the right command to run it on the command line. Just Maven run at the end. So this should work. Okay, so as I said, let's start on the DB class. So we first have to initialize the storage manager, and we use the DB class. Is that later on we will talk about different types of initializations, of course, but for now it's enough to see the basic stuff and how the basic stuff work. Okay, so as usual, we start with public, static, and we need an embedded storage manager. That's the first thing we need. And let's call it storage manager. So the storage manager ensures that the database is up and running. So it's kind of like the database management system, I would say. Whenever you want to store something, or when you want to load it and shut down it and start it and whatever, you have to talk with that storage manager. So it's kind of like the database management system, I would say. And then we need a second object, and I would call it, it's the root object. Normally it's the entrance point to the object graph. And in our case, there is no root object so far. That's why. So we use the company object as a business object. So let's say we are a company and we selling cars and whatever, and we need an application to do that. So we use the company as the root object, and for that reason, we create another object, another instance, sorry, public static, or let's call it final static company. And let's call it root equals new company. Just to make it clear for you, the company object itself, we use it as a root object or as the root entrance object to the object graph. That's it. Okay, so let's create a static block. just to ensure the initialization when we touch the DB class the first time. And here is the moment we create the storage manager, and we use the embedded storage manager, the embedded storage configuration dot builder. This is the method I mostly use when I initialize EclipseStore because it's the easiest way, and for me it's the most the easiest way to initialize. It's not able to do everything within the builder, so for some other functionality we have to use different ways to initialize the Eclipse, the embedded storage manager, but for now it's totally okay. So we said that we need 2 channel counts, and therefore we say set channel count to 2. It always has to be a number powered of 2. So it could be 1 channel, 2, 4, 8, and so on. A sweet spot, I always explain that a sweet spot is something between 1 and 4 channels. That's totally enough for most of your needs, I would say. What is the reason for that channels? I come to that later. Okay, set channel count 2. Then we have to define a set storage directory. Oh, I missed the full stops. No, come on, what's from DB? This set storage directory. Let's call it data. Okay, and based on that, now we are good to go. We create an embedded storage foundation out of that. So we could say create embedded storage foundation. And based on that foundation, create an embedded storage manager. And now this is an important part of, or an important step. We have to hand over the root object here, that because the embedded storage manager has to know what is the root object to handle that. And after that, we call the start method. That's it. Java 17 is okay if you use. 21 will also work. So also 11, I guess. So yeah, 11, 17, and 21 should be okay. Okay, so I guess this is all we have to do. So we created a storage manager. First, we started with the configuration. We created an embedded storage foundation, and based on that, we started the embedded storage manager, hand over the root, and started the storage itself. Sometimes there are some questions having multiple storage manager within one project. That's totally okay. You could do that. You could have as many storage managers as you want, or instances of a storage manager. This is okay to have that. If there are any reasons to have that, I'm not sure. I've never used it that way before. Normally, I collect my data within the company or the root object. That's okay. But you could have multiple storage managers. That is working great also. Okay, so that's enough for the DB class. We are good to go here. Let me just copy that for you. For those of you who are not finished, so just copy this to your class and you're good to go and follow me along with further code. Okay, so let's move on. We already created the domain objects. So let me just summarize that a little bit. We have a company, because this is also a question that many people always ask, okay, how to create the data structure. I already talked about that in the fundamentals training. So for now, it's a quite really straightforward data structure. There is one special thing I want to mention. The car itself. Oh, no, sorry, that's not the right one. The car itself has a brand in it. You see that? Each car has its own brand, of course. And there is also a list of brands here. Some might ask, okay, why is that? Isn't it enough to have one brand within the car? So in case of you delete a car, you will also lose the brand at the end. So, and let's say you delete the last car from a specific brand, you will also lose the brand itself from maybe list within a drop-down field, for example. And that's the reason why we have that brands also here in a second collection. And this is totally okay because it doesn't doubles the data at the end within the memory because there are only references. So that means the value or the values of the brand are still once in the RAM, and we double only the references itself. And therefore, it's okay to have that like this, and this helps in that case or in that structure. Okay, so let's move on and let's start with the controller classes. And I like to start with a brand controller because it's the easiest controller. There are two different interfaces, I would say. We have annotated the brand controller with the controller annotation. We call it /brand. So whenever we call it at the end, we have to call localhost 8080 brands, I guess, or brands, and then you will get a list of brands. You see that here. I changed that a little bit. Within the fundamentals training, I always use just a get to make it possible to call it within the browser. Now I used post and get, and also the delete. You will see that later on. So in some parts, you will need the postman to see the data at the end. But yeah, let's move on. So we need to return a list of brands. Okay, so let's do this. We just need the DB class, db.root.get brands. So this is what we need. So DB is a static class, so we can access it in that way. And again, it's not the way how it works within Micronaut, but let's keep things as simple as possible. So, but yeah, root is the main entrance to my object graph, and the root object is company, and company contains my brands, and that's the reason why I just use this line of code to return the brands at the end. So let's move on. Let's talk about the insert brand method. So the very first line we need is we have to check if a brand is already available. So we do that. We call db.root. We have to check this .get brands .stream .filter, and then we could add a predicate. Let's call each brand brand, and then we could say brand get name equals ignore case I would use, and then we could say data transfer object, which is handover up there, so it's the DTO. So we use the DTO get name, and this is the way we check if there is a brand which is already available. And let's call the find first. That's totally okay, and we will get an optional back. And after that, we have to check if this optional is empty, and therefore we create an if. Here we are. If, let's say, find first is present. So, and of course, we have to do something within the if it's not present, because that's the important state. We want to create a brand if it's not there. So otherwise, we just skip this, and it's okay for us to skip it. If it's not there, we will create it. So that means we create a new brand at the end. New brand. And now we have to map some point brand.setName, and let's get the name from the DTO get name. And now we have to insert that created brand. For that, we get back to the root object. Let's say root.getBrands.add brand. So first we have to add the new brand to all the other brands, I would say. And this is the point that happens within the RAM, right? So now we have to store it. So we have to ensure that this will be stored at the end. And I already explained that if we want to store something, we need the storage manager. Let's call db.give me the storage manager.store. And now this is really important. I always have to explain that you have to store the object which has changed. And because we added the brand to the collection of brands, we changed the collection itself because we added a brand. So that means we have to store the collection itself. That means we could copy that db.root get brands because this collection has changed, or this collection is the reference holder, and we always have to store the reference holder. Last but not least, we need a return, and we return an HTTP response. Let's say okay, and yeah, let's say brand. Yeah. Okay, that's the way it works within the brand controller. This is all we need. So there are a lot of stuff in it. We talked about within the fundamentals training. So we talked about how to access the elements. We talked about how to filter stuff from EclipseStore. So we talked about that we use the Streams API mostly to filter data. And we talked about how to store or how to insert elements. So that's the reason why I choose that example to repeat all that stuff from the fundamentals training. Okay, any questions so far? Everyone is on track? Okay, let's move on to the car controller. There are way more elements in it, but no worry. Mostly I will copy and paste the stuff just to save a little bit time at the end. It's the same on list of cars, so there is nothing special, and you could also copy it if you visit the master branch on GitHub, for example. Then you will be able to copy the code with me. That makes things a little bit easier, and I will explain it a little bit at the end. So what we really need is the db.root get cars. It's the same like within the brands. That's it. Then there is another get to get cars by model. I used a query value. Let me just stop. There is one question. Is it necessary to take into account the competition on brands? Is it necessary to take into account the competition on brands? It's a little bit hard for me to understand the question. Is it necessary to take into account on brands? You mean the brand within the car, or you mean the list of brands within the company? Is that what you mean? Okay. So the list of brands here within the company. Yeah, I already explained that a little bit. So the reason why I have that list is because of when we let's imagine we delete some cars, and let's say you delete the last BMW from the list of cars, you will also lose the brand at the end. So, and if there is a combo box, for example, with when you have a drop down with all the brands in it, you will lose the BMW brand. And that's the reason why I have a separated list of brands within the company, and that helps me to ensure the availability of a specific brand. So I think that's the point why I have a list of brand also within the company. Hope that answers the question a little bit. Multi-threading, that's a good point. It's part of the advanced 2 training. But for now, I have to say, multi-threading is a thing you have to deal with, basically. But for more detailed explanation, I have to I go into that within the advanced 2 training. So, and maybe you have access to some videos of an advanced 2 training, then you could see that. But it's a further topic, and it fits not to the advanced 1 topics, I would say. Okay, root is static. Yes, it is static. It's always static within EclipseStore. I would say, no, it's not really always static, but you need one root object as an entrance point to your object graph, and therefore it has to be static, of course. But the way we initialized the root object within the DB class, it's like this in a static way. It's not the way how to use this within a Micronaut application. I knew that, but as I explained, I tried to keep it as simple as possible and understandable for starting with EclipseStore, because it's not a Micronaut training, it's only an EclipseStore training. I hope that answers that a little bit. Yeah, in our case, last right wins. In that I did not deal with multi-threaded stuff so far. It's the easiest way to use EclipseStore in that case. Okay, so let's move on. Let's just copy paste this. It's the same. It's the same like always. I stream through the cars, and I use the stream keyword. I filter something, and after that, I need the collectors to get a list back of that. In that case, we need a list of cars by a specific model. So that's all we need at the end. And it's the same on the next method. So in that case, we need by brand, and we did the same by the brand itself. So just 2 streams to filter, and that's it. Okay, so then we have a delete method. So that means we have to delete cars. In that case, I prefer to delete all of them. So, and just to delete all of them, I use the db.root.getCars. Clear cars. .clear. So that means I cleared the collection, and then I have to store it. So db.storagemanager.store, and I changed the cars collection because I cleared all the references, and that's why I have to store the cars collection at the end. At the end, I return an HTTP response based, let's say, okay, and I could copy this. It makes it easier. Okay, cars cleared successfully. That's all we need. Last but not least, the insert. It's a little bit a bigger functionality. Let me copy this. And I will explain that a little bit more in detail. It's, nearly the same like with the okay, I have to check if the brand is available. So let's say if we insert a car, we first have to check if the brand is available. And if that brand is available, is present, then it's okay for us. So it's a really, really easy and basic example. Yeah, we could do some much more validation and stuff like that. So I just check for the brand. If the brand is available, I use that brand. I create the car, set the brand, set the model, and I have to store it, so I insert it and then return the car. And that's it. And yeah, as I already said, there are many, many more validations to do and take care about multi-threading and so on. But this is just a very basic example of how to use EclipseStore at the end. So it's the same here, the storage manager.store, and I changed the collection of cars because I added a car at the end. Okay, so that's it. So let me summarize that a little bit. We created an instance of a storage manager. We created a root object. We added the root object. And now we are able to use that application. So let's do so. So let me try this. I have the Postman up and running here on my second screen. So let's start the application. Okay, here we are. So let's jump into the Postman car exercise. Okay, here we are. This is my Postman application. So this is the collection. So this is the car exercise. And let's check for all cars. Let's see if that is working. So you see, when I started, or when I access the DB class, EclipseStore is initialized here. And you see there is a database already available. This is not what I want to have. So let me just stop this car exercise, because here you see that there is a data folder already there. We don't need that. So now let's do it again. So let's start the application again. Okay, so let's check for cars. Now it should be empty. You see that? Okay, let's add a brand. So let's use the add brand method. All brands, add brands. Okay, there is the URL missing. 8080 brand slash insert. Was it the right one? Let me just check. Brand controller insert. Yes, should work. The body. Oh, who deleted that? Insert brand. Here you are. So this is the right one. Okay, this is the post one. Okay, great. So that's the body. So let's check the body. So let's create a BMW. Let's set this localhost 8080. This is the right one. Okay, we get a 200. That's okay. So let's create an Audi. And another, let's say Ford. So whatever. So now we should have 3 of them. Just double check if the brands are here. So you see that I used the all brands method. Then we need some new cars. So insert a car. So here it is. This is the body. So Audi in small letters in lowercase, and then A8. Yeah, let's do so. Let's insert. The response is, okay. So I have to change 8080 again. Okay, there's the 200. Let's add another one. Let's say an M5, and this should be a BMW. Send. Okay, and now let's search for all cars. Here we are. You see the cars are created. So the interesting question is, what happened if we restart the application? So I stop the application and let's restart the application. And now let's check if the data is still there. And here we are. So we called it. You see, application is startup at the beginning, and I sent the all cars method, and I get back all my cars. Okay, so we did everything right. As I already explained, just check out the master branch. Everything should be in place on the master branch. And if you use the Postman or any other REST tooling, you could directly call the controller classes at the end. So some questions from your side. That's the exercise, the start of the advanced training, just to repeat all the basic stuff of EclipseStore and how it works. And that brings me to the next steps, configuration and so on. But for now, any questions from your side? Maybe some of you are interesting. When do we have the first break? I missed that a little bit to explain. I tried to do the break somewhere between 6 and I think that's okay. It's right in the middle of the training. So that is the opportunity to fill up coffee or tea or water or whatever. Okay. No questions so far. So let's move on. So let's talk about configuration. In the car exercise here, we use the builder pattern. And let me jump into that. So we use the builder pattern, and that is only one solution you could use to initialize. And therefore, I created another project, which is called MicroStream configuration. That's the next project we want to work on. Let me share the link with you first. Is it? Here we are. Okay, there are some more. This is the repository. And we have one question here. If, for instance, the car collection was huge, is there any way of optimizing search in order to avoid loading the whole collection into memory? Yes, there is. I'll come to that a little bit later when we talk about lazy loading. For now, there are many different solutions I would recommend. But in the future, especially within our enterprise solution, there will be a next, or there is, let's say, there is, currently there is a solution there. We call it the lazy collections. I will also mention that a little bit later. And especially in the enterprise solution, we are working on a thing that is called GigaMap. And it's the new upcoming a new upcoming great solution, and this is exactly what you are looking for. But I will come to the basic stuff a little bit later. Don't forget that. If I forget it then remind me, please. Okay, so let's talk about configuration. How to configure and why to configure that way. We used it for now. Let me just check if I'm in the right branch. So there we are. Switch to configuration done. Okay, let's use this branch directly, the configuration done branch. I think that's quite helpful to see the different. I would not type this for now because it saves me a little bit time to directly jump in. So the DB class. So it's also interesting to see what I explained before, that it is possible to have multiple storage manager within one project. So in that case, I created 4 of them, and each storage manager has its own root object. So that's important. It's not possible to share a root object within 2 storage managers. That could lead to some problems at the end. But having multiple storage managers, it's totally okay. And I created some initialization methods here, just to show you the different types of initialization. So, and all these different types are also available within our documentation. That's also a good point. I didn't share this with you. So when you have a look on the documentation of Eclipse Store, you will find the configuration part directly here, and you will see multiple different ways of configuration, also in the same way like I do, or like I provide you here. Just look at the documentation at the end. Okay, we have the basic one. So, and the easiest one, I would say, we only need 2 informations to create a proper embedded storage manager. It's the information who is the root owner, or what is the entrance point to the object graph. And another one is what is the storage path. So the path to my hard disk to store the data on it. I would say that's the most important information at the end. There are different ways to start at the end. So we used, when we have a look down here, so you see that this is what we used so far. We use that builder pattern. It's the second opportunity to do that. And in my opinion, when we use a straightforward Java application, I would do it this way. But it's also possible to initialize a storage like we do within a Micronaut or Spring project. It's totally up to you. You will not need an integration, especially for Spring or Micronaut. Even it is available. Of course, there is a Micronaut integration available, and of course, it is a Spring integration available, but you will also be able to do it the manual way, I would say. Okay, so build a pattern. Nothing special here. Set backup directory. That could look new to you. We didn't talk about backup so far, but we talked about channel count, but we will get in detail with that a little bit later. And as I said, create a storage foundation. This is also, I didn't use that before to set the root object, but that's also important to see that, because some of you might ask, okay, why is that module stuff ongoing here? So why we need that foundation, and out of the foundation we create a storage manager? And it's also always the same. You need a configuration, and based on that configuration we create a foundation, and on the foundation we are able to create a storage manager. The reason for that is in some cases different. So within the foundation itself, there are some modules, and sometimes it's necessary to set things on the foundation itself. So we are not able to set the root within the configuration. So we have to create a foundation, then we have to set the root, and with that we create a storage manager at the end. And then we need to call a start method. That's also important. So it's the second way to initialize. As I explained, the most recommended way, in my opinion, in normal, straightforward Java projects, if there is no special configuration needed. So there are some configuration, or there are some how to say, some settings which you will not be able to set it within the builder pattern. So okay, so next one is the XML style, I would say. This one is just Micronaut stuff, getting the resource. I'm talking about the MicroStream.xml or EclipseStore.xml file, which is down here. So you need to have some properties here, data and channel count and so on. This is also a possibility to initialize Eclipse Store. And I load that file here, and after that I use the embedded storage configuration .load method. So I have to hand over the resource and the resource path, and based on that I'm able to create an embedded storage foundation. It's the same behavior or the same way or workflow to initialize it and create the embedded storage manager with the root object. And I have to false start. It's the same. This is also working with some YAML files and whatever. So different ways to initialize. Last but not least, the most complex one, I would say, is to use the API directly. So without any convenience layer, I would say. So I would say that the builder pattern is a convenient layer, and also this one. This is the API itself. So that gives you every possibility to change everything. And if you have to use this this way to initialize. It is based on the same system. If you have a closer look to that, you see, okay, we create a setup. So we create a foundation, and to enable it to create a foundation, we need a configuration, and that's why we set the configuration here. We used it in the same way like the builder pattern at the end, and we set the channel count provider to 4. There is always a provider that enables you to create it. It's the same like here. So to set a specific type of backup, we use storage backup setup new, and at the end we create a configuration. On that foundation we say set root, and then we create the embedded storage manager at the end. It looks a little bit weird at the end. So, but yeah, if you look closer, it looks barely the same than the builder pattern at the end. Yeah, a little bit more advanced system to initialize EclipseStore. So what I did so far, I created a static initializer here to initialize all the storage manager at once. And let's do that. Let's see what happened when we now call. There is, I have to add, there is a get book method here, a get method, so that enables us to initialize that. So let's start the application and see what happened at the end. So now you see all the different storage manager are started, and there are also some backup handler, whatever. And what we see now is when we have a look on the left. So, and I also did not mention that so far. So let's click on refresh. Now you see all the different folders for the different storages. So we have the builder storage, we have the foundation storage. This one is the complex one, and there is the short storage and data. I guess data is what was it? So DB XML builder storage. What was the data at the end? Short storage is there? It was the XML one. Okay, great. Okay, so also for you, just let you know how this is working. How does the storage at the end looks like? So let's show in System Explorer. This could also be interesting for those of you who attend the fundamentals training. So this is the builder storage, or doesn't matter what storage we choose. Now you see that the different channels. So we choose 4 channels to write down the data multi-threaded to the hard disk. But I will explain that a little bit later. There is one file. This file is insane important. You should not delete that because this is the only way to reload your data, because this is the type dictionary. So let me just jump into that. So it's kind of like a repository or a dictionary to see what type of Java data type or data type itself is part of your storage. So for example, let's choose a simple string or a simple Boolean. A small primitive Boolean has the object ID 2, and each part within the binary file in the end of the storage itself consists or has its own type ID. And that's important because EclipseStore uses the structure within that type to serialize or to parse the binary part at the end. So it's important to take care about the persistence type dictionary, but you should not copy within the storage anyway. So that's let's jump into one of the channel files. You see there is one .dat file which contains the data itself. It's a binary blob at the end, and there is one transaction file, but this transaction file is only for database purposes only. It's not a file you could use for some thing to do's. I created the backup directly within here. That makes not really sense, to be honest, because when we lose all the data, the backup is also gone. But it's just for demonstration that there is a backup, but we talk about backups later. Okay, so that's the storage. And the storage, this is how the storage looks like at the end. Okay, different type of configurations which could be used by you. It's which one is totally up to you. Choose the right one for your needs at the end. Okay, questions so far? Then I would jump to the next topic, the next configuration topic. We already talked about channels. So and channels, that's interesting. We first need to know what channels are, and let me just so we was there. So yeah, channels are the possibility to write down data to the hard disk within multiple threads. So and each channel represents one thread, and it enables you to write down the data directly in a multi-threaded way. That could be helpful, especially when you want to write data in a high frequency. So that means you have to write many, let's say, binary files, documents, images, whatever. Then it makes sense to have multiple channels. And I would say it's also helpful when you have a lot of lazy stuff to load within EclipseStore. Then it could also could it be helpful to have multiple threads to read multi-threaded from the binary or from your hard disk. But yeah, it's the sweet spot is somewhere between 1 and 4. That's mostly what I use in the projects. I never used more than 4 because at the end it could have disadvantages to have multiple channels, because the data will be more and more segmented, and it needs time to bring the data together at the end. So but especially for you, when you have to write down a lot of different a lot of data, then it could make sense to have multiple channels. So as I said, something between 2 or 4 is totally okay, and that's good to have. How to change the data? Is it possible to change it from 2 to 4? Not the easiest way, I would say. It is possible to do that. And therefore, I want to share you a small project which is called channel migration. It's a feature which was implemented a few weeks ago or a few months ago within the EclipseStore 1 version. It's the channel migration feature. Let me share the link to you. Just a second. So that's the problem, or that's the link, sorry. Channel migration. And within that project, I think there is only the main method is really interesting for you. It's a normal, straightforward Micronaut project, and it enables you to change the there is one class which is called main migrate channels. It's only just a main class, and this is the converter we provide at the end, the storage converter. So what we need is one storage configuration, which is the source configuration. That means the already existing storage based on 2 channels, for example. This is what we need. And we need a second one, and this is the target configuration. And yeah, as I said, we want to change the channels from 2 to 4. And then we create this configuration. And at the end, we need to use the storage converter. And this converter takes the source configuration and merge all the stuff to the target configuration. This is how the transfer from 1 or from 2 to 4 channels work, because all the storage itself has to be converted with multiple folders and so on. It's important to do that configuration. Sometimes that could be helpful to know, okay, there is a storage converter, and you could use it to convert the storage itself and to convert the channels. And yeah. Yes, and you're basically right. So channels are equals to CPU cores. Not all the time, but it makes sense if you have 4 or 8 cores or whatever, to choose a real amount of channels based on the available cores. Yeah, that could make sense. Not always, but could make sense, of course. Okay. Okay, so let me just double check my topics I want to talk about. Okay, next topic would be exception handling. Therefore, I created another project with multiple branches in it. So let me wrap up my IDE a little bit and stop that project. Exception handling. Most of the time, we use try-catch for exception handling because we are a Java-based storage engine, I would say, and it makes really sense to use a try-catch to handle our exceptions. And let me share that project with you. So many projects at the end. Okay, done. Here we go. Okay, this is the exception handling project. Feel free to check it out, and let's check this together. So what happens inside here? Which branch we are? Team. Switch to. Yeah. Just have a short look directly to the exception handling best practice done, and let's jump to the book controller, and we need the DAO object. So I think it's always a little bit, yeah, let's say it's always best practice, or also what is the best thing which works best for us. So I want to give you some advices what is best practices at the end. And one thing is what I would recommend is having those data access objects at the end. So that means all the access to the database and stuff like that, it's part of that data access book, for example. So there all the methods, add book and clear books. And the interesting point is I used the micronaut mechanics in that project. So when we have a short look to the DB class, then this looks a little bit different. So I use the application context for this. That means you see that the data root is no longer static and so on. This makes more sense to have that in this way. And therefore, this project could also be quite helpful for you to create your own data provider projects, for example. But I used the builder pattern at the end, and that's it. So, and that brings me back to the data access object. So here are all the methods to directly access to the storage itself. So that means add books, clear books, list books, update multiple books, and yeah, in that case, we have to talk about this method here. And you see that when we talk about exception handling, there are two different parts or two different situations to handle those exceptions. The first one is the update of multiple books, for example, to get some transaction behavior. And therefore, there are two different storer mechanisms built in. When we use the normal store method, like always, let's say db dot, or let me just check what is the small one, db dot store. So that's the method we use mostly, and then we have to store something. When we use the store directly like this, we always use a lazy storer. So like this one here, a lazy storer. This is the default behavior. And there is another way to do that, which is called the eager storer. I also prepared a small application, a small presentation for you. Just a second. Legacy type region. No, it's not the right one. Here we are. So yes. Okay. So this is the basic store function we talked about. So whenever we want to change something, we have to store the data or the object which has changed. This is what happened here. So we changed the book. So oh no, in that case we create a book, and at the end we have to store the collection which holds the reference to that book. And if we update the book itself, for example, set the release date to local date now, we changed the reference holder of the release date, and that's the book. And that's the reason why in that case we store the book itself, because the book itself has changed. And it's always a lazy function, lazy storing function. And that means this is the default storing mode of Eclipse Store Engine. Referenced instances are stored only if they have not been stored yet. So, and referenced instances means all the instances which are referenced by the handover object. So that means when we call a store method on a book, and a book contains an author object as a sub-entity, and the author maybe has some more, let's say every author has its own orders, for example, whatever. So then all these sub-entities will not be stored at the end, except these objects are not stored, not already stored. So that means when you add something and the object you added is not already part of the storage itself, then it will be this will be stored at the end. But it's way too complicated to see that. Maybe you have to read that again within our documentation. But just to keep it simple, lazy storing stores only the object which is handover, and without the object, the sub-entities below. So, and if you want to store traversely, I would say, then you have to use the eager storing mechanism. That means not only the handover object is stored at the end, also all the sub-entities below are also stored, no matter if there are some changes in it. So, and sometimes this could be quite, could lead to a problem, because the storage or the Eclipse Store Engine works like an appending storage. So that means when we change an object, this changed object will be added or will be appended to the binary at the end. So that means when we call 20 times store on an object, exactly this object will be added to the end of the storage again and again. And there is one process that is working in the background, which is called We call it a housekeeping process. And that housekeeping process takes care about for deleting all that duplicate entries at the end. And now you see the problem when we call an eager store, for example, on the root, the whole storage will be attached to the end of the binary file, and that could lead to a bad performance at the end. So it's basically possible, but at the end you will have bad performance because you are storing the whole data again and again, and that's the problem. And therefore, it makes sense to have the lazy storer as a default behavior and the eager storer as an extended behavior, which could be quite helpful at the end. And to use the lazy storer or the eager storer at the end, you have to create one, create lazy storer or create eager storer, and that storer helps you to register the changed objects at the end. And if all changes are successfully, you could call a storer.commit. So, and this is kind of like a commit, so data goes directly to the hard disk. And this could work within a transaction at the end. So this is also, this is how it basically works. So that means EclipseStore does not provide explicit transactions. Every call to a store method is automatically a transaction. A store operation is an all or nothing operation at the end. If the store call is successful, all data is written to the storage. Otherwise, no data is persistent. So that means, let's say we want to store a data and we lose the hard disk, for example, for what reason ever. So doesn't matter. The data is not written to the storage and data is not persistent. So you will lose the last store call at the end. That could happen, especially when you use persistent volumes within Kubernetes, for example, and Kubernetes detaches the volume from the pod, for example. Then this could happen. But yeah, it's a rare situation, I would say. Partially persistent data will be reverted. We already talked about this. Okay, and there is one situation that is quite interesting. And that's also the reason why we always have to provide some kind of transaction at the end. The point is, let me just, is this situation. So let's say we're changing an object and we try to store the object. And something went wrong at the storing situation. What happens with the change instances in the RAM? So you will not notice that something goes wrong. So yes, you will get an exception within your logs, for example, but at a user or as a user on the application itself, you will not notice that this is not working properly because the RAM is changed. You will see the changes within your application. So, but it's not stored until you restart the application. Then you will see, oh, all the data is gone. And that's a big problem. And that is exactly the point why we have to deal with some rollback mechanisms at the end. And that brings me to that example here within. Whenever something goes wrong within here, we have to do it within a try catch. And after that, we have to take care about some rollback stuff. But let's talk about this a little bit later. First, I will give you an idea how to initialize those specific storer classes. So let's say db.getStorageManager. And then I could also create an eager storer. So this is these are the two possibilities. Let's call it ES. And now I could use the ES at the end instead of LS. So eager storer stores all the object traversingly, and laser storer only stores the object which is handovered. In that case, it's B for the book itself. And the commit is, or the store itself registered the object, the commit transfers it directly to your hard disk. Okay, so let me just check if there are some questions. Yeah, this is exactly what I explained. The store method, yeah, sometimes it's a little bit unlucky, the wording here. Store means kind of like register the object within the store, and commit does the store at the end directly. The commit is persisting the data to the hard disk. Yeah, it's a little bit unlucky, I would say, but yeah, we are not able to change the API in that case. Maybe in some new version we working on that change to make it more readable at the end. Okay, so we use the try catch at the end, and we have to take care about the rollback. And let's come back to this. So let's change let's change the branch to give you an idea how the rollback works. Let's discard it. And I created one best practice example how to use the rollback. And you see that here, update multi-books. It's still the same method. And I use the LegacyStore here. Then I go through the books and I set the price of to 50. And at the end, I say, okay, ls.store b, and I try to commit it. If something goes wrong, we will move to the catch clause. Of course, I need to do some logs, stuff like that. And then we provide a reloader. And the reloader works in two different ways. In that, so yeah, we create an instance of the reloader. And we have to hand over the persistence manager of the current storage manager. So that means we go to the DB, get storage manager, give me the persistence manager. And after that, I could reload, or I could say, okay, books.forEach, these are this books here, b.reloader reload flat. There are two different methods. One is reload flat that rollbacks the object itself. It's kind of like a lazy rollback, or sorry, a lazy reload. And there is another one which is called reload deep. And this is the eager version, I would say, of the reload. And that brings you, that loads the data again from the hard disk and reverts your changes after that. So whenever you need some transactions like this, you could use it in this way by using the reloader. And with the reloader, you could say reload flat and reload deep. Okay. That's a good question. Recreate the reloader. I guess yes, you have to do this always, but it seems that it could work if you create one reloader because it only needs the persistent manager at the end. And then you need the instance because you hand over the object which has to be reloaded anyway. So yeah, it looks like it is okay to have one central reloader. It seems so. But okay, yeah, I have to double check this. Okay. Let me take a note of that. So I would ask my colleague for that. Okay. Okay, any questions? Yeah, reloader example, it is part of the exception handling project I shared with you within the rollback impl done branch. Did you get the URL to the exception handling project? Within that project, you will see that DAO class, DAO book, and there are also some example methods. So there is update book non-store. I created an example. Let's do so. So let's check it out if this is working as expected. So we could do this before we go into the small break. Let me run this as a Java application. And if we jump into the book control, there must be a method that is called rollback flat, rollback deep, update book non-store, update author non-store. Okay, so let's try it out. So a localhost, I guess books, right? So books, and then slash update. What is it? Update book non-store. So let's use this. So let me share this with you. So this is the let's call the book the book method. You see all the books are currently in the storage, and let's call slash update book non-store. So name of the book successfully changed from Star Chamber to Java the good parts. So let me double check this. So you see that now the book is named Java the good parts here. And this is a change which is only made in the RAM, right? So we didn't persist that. And now we are able to reload that. So what is the, yeah, rollback flat. So let's go rollback flat. Book successfully rollbacked. You see the name is again Star Chamber or the Star Chamber. Okay, this is how the reloader works, and this is the project for it, especially the branch rollback implementation done, or rollback impl done, and that helps you to see what's happened there, and there is also an example with that. Okay, there are one situation within that project I want to talk also, but let's go for a short break for now. It's 6:30, I would say, or let's do it till 6:45. So that's okay. So I can close that topic at the end. There is a second part I mentioned at the beginning where the exception handling could be quite helpful. It's within the DB class. And it's the same situation. What happened if something goes wrong? That's always that could always be the case. And you see that here, I created some additional store methods to, yeah, how to say it, within. I wrapped the normal store method and ensures that everything at a store works like expected. And the reason for that is if when you use EclipseStore, you might say, okay, what could go wrong? So there is no internet connection to a database anymore. It's pure Java. We just have to connect to the binary, to the hard disk. So then, okay, what could go wrong? Basically, there is not that much possibilities that could go wrong, but it could be. And especially for that situation, you have to ensure that it makes sense to have stuff like this, because whenever something goes wrong, it must be, yeah, I would say it's dramatically, because something really have to go wrong that EclipseStore fails at the end. We have examples on our customer. Application are running for months without any problems. But if something goes wrong, then it could be a worst case. And therefore, I always recommend to create stuff like this. So to wrap those store methods and add some on storage failure. And I always recommend for shutting down the storage at the end and ensure that the application is not restarting, because you have to check what's going on here. The reason for that is I already explained that when you write down to the RAM and something goes wrong in the background, you will not notice that as a user. So you see the data, the RAM is okay, you change the RAM, but you did not notice that the store isn't not working in the background. And based on that situation, you have to shut down your application and see what the problem is, instead of working along and after that, if you mention that after 1 day, you will lose the whole data of that day. And that's important. Try to implement stuff like this. You will find, this is just an example. I'm pretty sure you will find much more better solutions to handling those exceptions. It's just an example to give you an idea what the problem could be at the end. So, and implement it in your way, and how you like it, and then it's totally okay to handle that. And it's the same on what about external events? So, and there is one example project I brought to you, and you could use some listener, or you should use some listener like this. So, for example, Micronaut provides some events that could happen externally. So, for example, the server shutdown event, especially when you use the Kubernetes, for example, and you always have to ensure a gracefully shutdown of your application. That's important because when you use EclipseStore at the end and you remove the persistent volume, for example, then EclipseStore is in trouble, maybe. So because EclipseStore is only able to write half a binary file, and that could lead to a problem. I'm pretty sure there are 100 times that it works okay. You will not have any issues on that, but on 101, you will get an issue at the end. And therefore, I always recommend a gracefully shutdown, and those methods will help you to ensure a gracefully shutdown, especially when you call I don't know the command for Kubernetes to stop a pod or something, but yes, you could do it this way. It's just an example. I will share you this code. It's especially for Micronaut. It's not only an EclipseStore thing, but it could help you to implement this. Yeah, gracefully shut down. It's important to mention that. Okay, any questions so from your side? I think that's all I have to share with you regarding exception handling and gracefully shut down and configuration of the storage itself. I like to share the 2 additional examples, one with the S3 bucket, how this is working, and the Micronaut integration I want to share with you, but I would recommend doing this after the break. Okay, so before I move on directly to the lazy loading part, I just want to share with you 3 additional example projects, I would say. The first one is one example of storing data directly to an S3 bucket as an example. That could make sense in some ways. For me or for our customer, I always recommend storing data directly to the hard disk because, yeah, it makes sense. It's quite fast to have it. If this is not possible, it could make sense to store it directly to an S3 bucket. At the end, especially with a project with not that much lazy stuff in it, it makes no differences because the data is in memory anyway, and you only have to load the lazy parts. And if the lazy parts are not that important, or you don't need that much performance on the lazy parts, it makes sense to use an S3 bucket as a storage also. Because the only difference between S3 and the hard disk is if you need to load data from the binaries. And yeah, the fact is that EclipseStore is an in-memory database. Mostly you will operate on the memory. Is it necessary to include only the commit method or both commit and store in the try catch? Yeah, you have to have the store method to register the changed object and the commit for storing it to the hard disk. So, and both should be part of your try block. And if something goes wrong, it switches to the catch, and that gives you the possibility to reload that stuff. So commit and or store and commit should be both within the try. And it's not only because of transactional behavior, it's also, let's jump shortly in that. It's also because it's much more efficient to have that in this way. So you could imagine that when we so we could also do stuff like this, right? So let's disable that. We could do something like this, db.store b without this stuff, right? So, but what is the disadvantages of using EclipseStore that way? I mean, it's quite clear because you always have to store it, and this will lead you to bad performance because on every iteration you have to go to the store itself. It's a blocking request, so that means it blocks your iteration through the books at the end, and that is the reason why you should not do this way. It's much better to use a store like this, register the changed book within the LegacyStore, and if all books are iterated, at the end you could call the ls.commit to store it to the hard disk. And I think that's the idea behind not only transactional behavior, also to find a way to do some bulk changes with good performance, I would say. Does that answer the question? Okay, great. Yeah, as I said, so we don't need to save that. I'd like to share the S3 example. So this should be the S3 store target project. I already opened it here, and it's also quite really straightforward. It's a Micronaut project, and we only have to check the configuration. And it looks like this. All of the different store targets are based on the blob store file system, for example. There is also one example within our documentation. So let's jump into that shortly. Good question, where to find that. No, where is it? Storing data. Loading data. No, where is it? Is it configuration? Storage files and dictionary. No, it's not. Or sometimes it's quite hard to find. No. Give me just a few minutes to remind that. But it's in the documentation. Maybe I have to use the search functionality. Yeah, you just have to create a blob storage file system, and that enables you to set this as the store target at the end. You see that the way to initialize is quite the same. In that special case, you will need your AWS security stuff, your secret key and stuff like that. In my case, I added this as an environment variable. I think that's the way to go. And then you have to create an S3 client on that. Let me just share the POM XML with you just to show you what type of dependencies you need at the end. You see that you will need the storage embedded as always and the storage embedded configuration. And on top of that, I added the normal AWS S3 bucket API. And this one is from EclipseStore, and this one is from Amazon itself. not sure if I need both of them. I need to check that, but this is working. You could give it a try at the end. Let me just show you how this is working. So we need the application. Oh no, I use this one, and that should be the right one. So let's start this. So this is, let me share the S3 bucket with you. So you see that this is the bucket itself. It's empty for now, no options or no objects in it. And when I try to access the database, just a second, so localhost, here we are. Let's check for some books. So localhost 80 books. You see the Eclipse Store is initializing. And when I now refresh, you see the bucket entries here, and there is no surprise. There are the same objects. The objects are the same, like on the hard disk. It's quite the same. So the result is empty. This is also no surprise. So let's create some books. So let's check if the books are available. Now we are able to shut down the storage itself, and let's start it again. And now I think that's the real differences between S3 and a persistent volume or the file system or the underlying file system directly. On startup, it needs, yeah, for sure, more time because data has to be loaded directly from the binary on startup. And I think that are the main differences between S3 and the file storage. So let's call for the books. You see, it needs a bit longer, but the books here are around 1,000 of books are inside here. Yeah, it works quite fast, but regarding performance, we are talking a little bit later. Okay, so this is how to use S3 bucket. That was one project I want to share with you. A second one is the Micronaut integration. Just to let you know, there is an integration available. You see that here. You will also find on our GitHub repository one example of that. I'm not able to share this project, but I just want to have a short look at it. You see there is no more DB object anymore. Instead of that, we're using that application properties here. And we do some adjustments here, especially for the housekeeping and channel count and so on. And that's all we need. Everything else is handled within Micronaut. We do the Micronaut startup event. This is the shutdown. I already shared that with you. Yeah, and so on. There is nothing special in it. It's the pure Micronaut integration. You do not need that DB class anymore and those instances. It's all the stuff is handled automatically in the background, and that's it. I think it's enough. Just have a short look to the documentation. There is the link to the Micronaut integration, and that's it. We could double check the dependencies. Oh, that's the wrong one. We have to choose this one. Yeah. So you see that it's based on version 1.0. It's an older version of Eclipse Store. We are currently working on an upgrade, especially for Micronaut. And you see these are the Micronaut dependencies you need to use Eclipse Store at the end. Okay, that's it. A more interesting project I'd like to share with you, and this is also related to all that configuration stuff, is the possibility to having the main storage on the binary file, and on the other hand, writing a backup mirror to an S3 bucket. And this is a project I created a few weeks ago. One second. It's already here. And I come to that later, backup strategies, because this is a project. Let me share that directly so I don't have to do this later. But yeah, here we are. So as I said, I will come to backups later on, but just for giving you an idea what is possible when we talk about configuration and this that fits best. And you see that there is one branch which is called Backup Strategies Continuous Backup S3 done. So the continuous backup is kind of like a mirror, which is written directly at when you persist something to the normal storage, a mirror will be written in the background. And that mirror could be directly on an S3 bucket. So that means that is one type of backup strategy. And to achieve a behavior like this, it's necessary to use that, let's call it complicated way to initialize a storage manager. But you see that we need that backup setup here, especially for that. And that's why we provide a backup S3 file system. And that means the mirror will be written directly to the S3 bucket at the end. And here is the definition of that file system. It's basically the same way how using the S3 bucket as a primary or as the normal storage. You need that blob storage file system, but in that case, you use it as a backup setup. So that's also possible. There are, as I said, there are many different thousands possibility how to initialize, how to use EclipseStore as a storage, and so on. But I think it's important to share this with you. Okay, that gives you an idea how it could work at the end. Okay, let's have a short look together to the list of topics for today, just to ensure that we not forget something. So here we are. So we talked about, or we did the warm-up exercise. We talked about configuration in advanced, exception handling, gracefully shutdown, S3 bucket, micro integration. Storing advanced, we talked about eager and lazy storing, transaction and rollbacks. So we are done with the left side of the topics. And we are right in the middle of the training after the break. And that enables me to jump to the next three topics, the lazy loading, the type mapping, and the EclipseStore backup handling. Okay, are you ready? So let's move on. Sometimes it's a little bit confusing jumping through all the different topics, but yeah, it is like it is. So, okay, so lazy loading. I'm gonna start with a small presentation to give you an idea. What do we talk about when we talk about lazy loading? So, yeah, here we are. So, lazy loading. So first we have to clarify, why do we need lazy loading? And for all of you attendees from tomorrow, this is the presentation you have already seen. So now you have a short break, I would say. We have to clarify why we need lazy loading, what data should be stored and loaded lazily, and how to use the lazy references, best practices, and how to release. So these are the topics of lazy loading, and it's, in my opinion, it's one of the most important topics so far, because it's not necessary to have all the data all the time within the RAM. So we need those this lazy reference functionality. But EclipseStore basically is an in-memory database framework, and that's the reason why it is so fast and performant. So that's quite clear. That means best performance. You will get best performance only if the data, or for best performance, data has to be in the RAM. That's for sure. But as I said, but in some cases it's impossible, or not needed to have all the data, or unnecessary to have the data within the RAM. So we have to make some decisions, what data should stay on the hard disk and which one do we need within the RAM. By default, the whole data will be loaded into the RAM on startup of EclipseStore. So that's that's the case. That means if we have 100 million objects within the storage on startup without lazy loading, we will have 100 million objects at the end in our RAM. So that's okay. That is how EclipseStore basically works. But we are able to set some lazy points. Maybe here or here or here. It depends on you. The lazy functional is kind of like a wrapper class, which is which is wrapped around some other classes, but you will see that later. And if we have 100 million objects, at the end we have, let's say around 500,000, for example, because of these objects stays on the hard disk as long as it is needed. So that means when we have lazy here on 1, that means 1, 6, 7, and 4 stays on the hard disk. So when we load the 1 type, we will get 6 and 7, and 4 stays on the hard disk because 4 is another lazy reference, and you have to call the get method of that lazy reference to loading the data at the end. And it's the same on the right side here. As long as 4 is lazy loaded, it stays on the hard disk as long as it is needed. So the question is, in general, I would say, when to use lazy loading. So lazy loading is always makes sense to have lazy loading on binary stuff. So we're talking about blobs and documents, images, whatever. So whenever you have those stuff, you should have it the lazy way. You should have it always on huge collections with less frequent data. So the question is, what means huge collections? I would say it's a little bit on you to make a decision. Okay, this could be, let's say, this is archive data that is not needed, or someone will call it once a month or once a week, and it's not needed to have that in that high speed performance. So then it's okay to have it within lazy loading references. And sometimes with huge amounts of sub-entities. That means, let's say we have some entities, they consist of 100 fields, for example. Then I'm pretty sure not all of that 100 fields are really needed all the time within the RAM. Then it could make sense to have one master and one detail entity. The master contains the 10 most important fields, and then the master is already available or all the time in the RAM, and the detail is lazy loaded within the entity itself. And that means that data stays on the hard disk as long as it needed. So I think that's how it could work, basically. Or whenever you want, if performance isn't that important in this part of data model, or the amount of RAM is limited. What you have always to consider is the point that the more concurrent user you have, the more data will be within your RAM anyway. I give you an example. Let's say we have 1 terabyte of data on the hard disk. So that means we have 1 terabyte on the hard disk. And let's say we are able to start EclipseStore with some lazy, and EclipseStore fits within 8 gigabytes of RAM. That's basically possible. So most of the data is lazy loaded, and only the most relevant data is part of your RAM. So what happens if, let's say, 3,000 people starting to work on your database? That means all the data which is on the binary will be loaded at the end. So you always have to find a good point of what data is really within the memory all the time anyway. Then it makes no sense to load it the lazy way. So if it stays in the memory anyway, don't define or don't make a definition the lazy way, because the data is in memory anyway when people starting to work on it. So that is an example, especially for binary stuff. So you could do it this way, lazy byte. I would say that's the easiest. Not by far not the best way to do this, but A better way could be down here, so using a hash map. And that's the first spot I want to share with you. There are not only sets and lists possible with EclipseStore. Sometimes a hash map makes way more sense than any other collection. And this is one example of that. So whenever we have some lazy bytes here, and lazy, this is the way how to make a definition that the data stays on the hard disk. And the string contains, let's say, a short description of what type of image, let's say, or what kind of document is in it. And there was a question before the break, how to search within a list or something like that without unwrap it or without searching through the whole list. That could be a solution for that. Creating your own index within the string or whatever within a hash map. And this is one solution which is a very good way to handle a huge amount of data. For example, let's say we're talking about books. This is more a topic on the fundamental training at the end, but for those of you who not attend, let's say we have books here, a hash map, and we have millions of books, for example. Then it could make sense to have a string here with the first 4 digits of the ISBN of that books. And then we have a list of books at the end here. And that brings you the benefit that you could search for the specific ISBN that is interested for you, and you only have to load just a few, not all of the books at the end. So that helps a lot to define a proper data structure to handle lazy stuff at the end. But there are some more opportunities. Let's move on a little bit for you to make it more understandable. Okay, as I said, when you call the get method, the data will be loaded at the end. And okay, so best practice using a hash map. Yeah, I already explained that instead of list and set. Lists and sets are great collections, I would say, but they are not made for huge data. So the definition of huge, let's say a million of objects. Maybe it makes sense to use different collections at the end. So this is the way how a lazy reference is instantiated. So in that case, we're using lazy on a list of books. That could make sense have this here, especially when you are okay with saying, okay, this list of books is loaded once a month or once a week, and that's it. Then it could make sense to have it this way. But you always have to consider that when you want to stream through that list, you always have to load the whole list at once. You could say, okay, that's okay. It's not a huge list. It's a medium-sized list or a small list. You don't care. So I would say, so then, yeah, the application server could deal with that. So that's okay. So, and that's why I would recommend this as a best practice way for low and medium-sized collection. But yeah, it's always on you to ensure that this is working as expected. Same here. This is what I explained with the ISBN. That could make sense to do it this way. And this could also not only be a string with for the ISBN, for example. Let's imagine that could be an author, and there are thousands of authors with their books at the end. So, and you have a lazy list of books, so that gives you the possibility to search within the authors, choose the right author, and then you could list the books of that specific author at the end. And there are many more possibilities. As I said, I explained that within the fundamentals training. The good thing on that is, for now, it seems a little bit confusing, but the good thing on that is that now you will be able to design an object model that fits best to your application needs, instead of creating an object model which fits best to a relational database because of Hibernate. So, and that gives you so much more benefits of your data model. It's not that easier. to change that. It's a kind of a mind change using an object model, but this is working really great at the end. And yeah, let me explain that a little bit later. Okay, there are two strategies to release loaded data. One is the automatic way and one is the manual way. You see the manual way down here. So that means you could clear a lazy reference. So that means, okay, let's say you loaded some data and you want to clear it, then you could use the clear method on the lazy object itself. The problem on that is you will need the garbage collection at the end to really clear it. So that's why I call the garbage collection down here in addition, but that is not the best practice. But just to remind you that you could clear it, but in the end, the garbage collection is responsible, is in charge to clearing, to really clear that from the RAM. But there is another clearance, an automatic way, and you could see that here. This is the default implementation of the lazy reference manager, and it clears data after 30 minutes if the data stays untouched within the RAM, or if you reach 75% of the memory. That is how the default behavior works, but we will have a look on that a little bit later. But yeah, just to let you know, this is how the lazy stuff is working. But the more interesting part, I would say, comes now. Let's do some research on that. Let's see if how this is working in practice, to give you an idea or a feeling how this would look like within your project. So I created one project which is called Lazy Demo. Just a second, as always, I have to share it with you. Lazy Demo, here we are. Okay. That's the project. And I'd like to start on the very first branch, team, the master branch. So that's the starting point. Yeah, one lazy checker for the whole instance. That's right. Yeah. Okay, so it's a really straightforward example. There is one domain class, which is person, the DB, as always. I use a person JSON for mockup data, and this file contains 1,000 persons, and I added a huge string on each person. So for the reason, just to give you an idea what it takes to write down heavyweight data, for example, to EclipseStore. So that's the person JSON. And when we have a look to the person controller at the end, there is one method which is called create persons. And as you see here, there is an int stream 1 to 200, and for each we create those persons. One that means every call creates 200,000 persons for each call. Let's see how this works. For some more details, I started the visual VM, so we could see what happened on the RAM. And yeah, let's do so. Let's try it out. So this is the application itself. Let's start up. Okay, so I prepared my Postman on a third screen. So let me just move there. Lazy exercise. Here we are. So I have a few methods here: person create, person's ID, and so on, for some further details. So I will create that method, person create, and let's see what happened on the visual VM. So here we are. So let's jump into that application. Let's do some monitoring. We do not need the threads And also we do not need the CPU. It's not that important. The interesting part is, so you see that EclipseStore is not initialized so far. So there is one method to initialize it, just to initialize the storage itself. Let me just check. Person controller, yeah, init. It's called init. That makes sense. So let's say, okay, localhost. So localhost 8080, I guess persons. Yeah, /init. So you see, the JVM is working. Okay, stop it. Stop it. So there is already a storage inside that project. So let me see demo check. So I have to delete the data folder. Okay, now we are good to go. Okay, again, here we are. Monitor. This is not needed. So let's call the init method. Okay, nothing special is going on. Let's call the first 200,000 persons. So let's send this. See that? This is running. It should take around 11 something between 11 seconds, and let's see what's going on here. So you see that, yeah, 11 seconds for creating 200,000 person objects. For now, we need 1.5 gigabytes of RAM around that. We could do a garbage collection, so we will see, okay, it needs around 1 gigabytes of RAM for that 200,000 persons. We could have a look on the data side, so on the binary side. So let's see how much memory do we need for that. Show in System Explorer. So here's the data. Let's see. So you see, we need around, yeah, I would say 2 gigabytes of data. Makes around 1 terabyte of data within EclipseStore. So when we compare that, let's do garbage collection again. Yeah, around 1 terabyte. So this is the relation between. So when we do that again, maybe it needs some more calculation. So now you see that we have 2.3 gigabytes. Windows needs a little bit to balance the memory on the hard disk. So when we do it as a third time, so you see that it needs a little bit to write down all that stuff and to handle it. Now, I think now this is the final result. So the size is 2.5 gigabytes on the hard disk, and within the RAM, we are at around 1 gigabyte. So let's call it again. Another one, you see, another 200,000 objects are stored to EclipseStore. That's it. So some more, 600,000. So it takes around 11 seconds for creating those elements or objects. Okay, here we are. So the good stuff is, okay, this is the data. It needs that much RAM. That's okay. So now we're talking about 600,000 objects within the RAM. On the hard disk. On the hard disk, it is, let's say, properties around 5 gigabytes on the hard disk. Just to give you an idea of what the ratios are. So around 5 gigabytes on the hard disk. And when we do garbage collection here, so we are around at 3 gigabytes within the RAM. That's okay. So that means the data is in memory, and this is quite fast. So that means when we want to have all that persons, so let's call that, let's give me all the persons. You see that we only need, the problem is that the postman is not able to handle that much data in a proper way, but just the request itself takes only 200 milliseconds for around 600,000 rows at the end. This is the power of in memory, I would say. And this is the real benefit. And it's the same, it's in the same way fast when we do some streams and stuff like that. This is really incredible, handling data in that way in memory. So it's amazing to work with that. Okay, but as I said, sometimes we are not able to have all the data in memory, so we have to deal with lazy stuff at the end. And yeah, let's move on to the next example. So let's choose the next branch. So we do not longer need this one. So let's move it to the next screen. So let's stop it. Delete the storage. We don't need that anymore. And let's move on to the next branch. Switch to change to lazy. Let's have a short look to our root object, the data root. So this is how it is initialized for now. So this is, we now used the lazy initialization. We wrapped the list of persons within the lazy, and we used the lazy.reference way to initialize it, some get and set methods. Let's have a short look to the DB class. You see there is no lazy reference manager available. So that means the default one is working in it. That means 30 minutes after. And yeah, that's all we need to know so far. Okay, let's start and let's see what's going on when we now start the application. Okay, so by the way, sorry for switching that screens that fast. So it's always quite difficult to show all that windows at once. So okay, so I start to send or to create some persons. Need to find the right one. Persons create. This one is the right one. Okay. So we only need to see the first 200,000. It's a little bit different now, or it should be a little bit different, because now we have to calculate not only the persons itself. Now we have the persons, and on top of the persons, we have the no. In that case, not. It should look like the same. I would say after garbage collection, it's the same. And you see the data is in memory. So if we would wait now 30 minutes, we would see that data goes down because of the lazy clearance at the end, if the data stays untouched. But a better idea is now to restart the application. And it's loaded the lazy way. That means when we start the application, we should not see a memory consumption like this. So let's try it out. So let's stop the application and start it again. And when we now jump in, and I just use the init method now, just to initialize EclipseStore, data should stay on the hard disk. You see, EclipseStore is initializing here, and you see there is no memory usage at all, only the basic memory usage, I would say. But at the moment we want to see the data, so let's click on give me all the persons. If we stream through, you see EclipseStore starts to load the data, and this is what it takes to load that 200,000 objects. And after that, these objects stays in the RAM, of course. And if we click on that, now we are at 54 milliseconds to to load that 400,000. After 30 minutes, the data will be cleared. So let's do so. Let's change the settings a little bit. So let's activate the lazy clearance to 1 minute Java time. So that means after 1 minute, the data stays untouched. It should be automatically cleared from the database. So we do not longer need this. Let's start it again. Here we are. Monitoring, do not need that. Postman. Okay, let's just load the data now directly. So let's see what happened when we load the data. You see, database has to initialize. Data is loaded, and you see that we are at around 1 gigabyte. And now we have to wait 1 minute. So we started to load the data at 7:43. Let's see, after 1 minute, that gives us time for your questions. So if there is something you need to know, more detailed, feel free to ask. So we have to wait that minute anyway. So hurry up, only 20 minutes, 20 seconds. So this is what I told you. So we have to there is, as far as I know, I'm not exactly sure, there is no way to doing that, handling types in different lazy times, not so far. Yeah, I think that's the point. I've never used it this way. So there's only the possibility to set one specific lazy time for one special type of for all the types. Okay, when we now click on perform garbage collection, you see that the data is gone. This is what I told you. We need the garbage collection at the end to clear the RAM at the end. But this is just for demonstration, right? So if memory is needed, the JVM would take the RAM or would do garbage collection anyway. So this is how the clearance basically works. Okay. How does that feel to you? Is that okay to having such a feature? Yes, you're right. That's great. I will take this as a feature request. That's a good idea. Let me just take a note of that. Using annotations. Yeah, we already talked about this using annotations a little bit more, especially on the new enterprise features to create indexes and so on. That could be a good feature request also for lazy configuration stuff. Yeah, yeah, it's a great suggestion from you. Thank you. Yes. So I read the question. If you add an object to a lazy referenced collection, you would have to store the owner. Does that mean that you have to load the lazy collection into memory in order to store it? Yes, you are totally right. That's unfortunately that's the truth, and that's also the reason why we not really recommend to use a structure like this, because it's exactly based on that. To be more precisely, it's not it's you do not have to load the whole lazy list, but you have to store the whole list at once without the values, but you need to store the lazy reference also. It's something in between, but that's the reason why we are working on that giga map, for example, and some other solutions that enables you doing that. And that is also the reason why we recommend using hash maps or maps in general instead of using lists and sets with lazy. So that is just an example to give you an idea how the lazy basically works. But I would always recommend using maps instead of lists when we're talking about lazy stuff. And that's also the reason why all the other. So I think that's the basic stuff how lazy basically works. The more important thing is what type of structure should be used with lazy loading. And that brings me to the next branches at the end. So let me just switch the branch. So team switch to, and that's why step 2 would be a change to map. So this is what we already seen within the presentation. It makes more sense to have a structure like this, and that improves the solution a little bit, not to loading the whole list again to add something. So, so you only have to load small chunks of persons and add a specific person to it. So that improves that situation a little bit. And on top of that, we provided another solution, an embedded solution, especially for nexting. So let me change. This is the next step. Oh, no, the next step is multi-maps. That could also help, or this will also work. And in this case, there are person and persons. Could be a little bit confusing, but it could look like this. This is also a good opportunity or a good possibility to store data, having multiple lists with the same data with different indexes to handle it the lazy way. So here we have an persons indexed by the last name, for example, or we have person indexed by the first 2 digits of the male, and it's by the way the same on last name, by the first 2 digits of the last name. So to creating an own index, to creating smaller chunks. And this is, by the way, the same situation like on, you remember the author and the book itself, and it doesn't doubles the data having stuff like this. That means all the persons within the list are only references. The data stays in memory only once and not twice. And of course, you have to take care about those persons always in both lists, that's for sure, but that could be a good possibility to have that. We also provide, and that brings me to the next branch, we provide some lazy collections. That means there is a lazy array list of persons. These collections are based on the normal collections of the JDK, and these elements handles the lazy loading chunk-wise. That means you are able to define the number of objects within a chunk, and then you could use those lazy array lists or lazy set or lazy map, and all the lazy stuff happens behind the scenes. You don't have to care about that. I would recommend using those collections, especially for, let's say, archive data, for all the data which is not needed to have that in a high performant way. Because you could imagine all that loading chunks and stuff like that, that will lead to not the best performance, I would say, but it doesn't have to, because lazy data is not the data which is needed in high speed. So it's okay to wait for it if it's, let's say, loaded once a month or once a week. So performance is not that important, but this is what you could use. I'm really looking forward to that GigaMap functionality. This will be a really, really great collection, which is in test for now. It's not released so far. And this gives you the possibility to use that map for, let's say, billions of objects. And you will be able to create an index based on specific values. And that is an insane component. I'm really looking forward on the release to that. It's at the moment it's on test. Yeah, we will see when we will release it. Okay. Last but not least, one solution which fits great for me in all the current existing project, and this is the last one I want to mention, is this one. A fully lazy map. It looks like this. So the idea is having a string as an index, which I'm able to search within. That you could also imagine some solution with what is the name of that Elasticsearch or Lucene, Apache Lucene, for example. So creating a Lucene index based on a specific string or the index here. So you're searching within Lucene and loading the data at the end. And let me just start up that example. And that is a good mix between performance and saving RAM at the end. And you see in that specific case, I used the mail, a random UUID string, as a key index. And this is working really great. So let me just show you that. Oh, just a second. I have to do maybe an update. Okay. Startup is done. So let's monitor this. Okay, so let's create some persons. At the moment, it's empty. The storage is empty. So you see, memory is increasing basically. And in that case, this is what I mentioned earlier. Is, the disadvantage on that solution is there is a little bit the memory consumption is a little bit higher than normal because of that lazy references. Because now when we have a look to the data root, you see that each person within that map has its own lazy reference. So, and this lazy reference is a normal Java object, but it needs RAM anyway. So because each Java object needs 16 or 32 bytes, stuff like that, doesn't matter, but it needs memory. And this is the disadvantage of that, but it's a good mix of RAM consumption and performance. Let's create some more, around 600,000, I would say. It's a good value that enables us to search within, and then you could see the performance of that. So that's okay. Let's create another one. So now we have around 600,000. That should be okay. Okay, so it's done. So let's have a look to the memory consumption. We have, yeah, around this, barely the same, 3 GB. That's okay. So now we have everything within that map. Let's restart that application. So now we should see the memory consumption when we initialize the storage itself should be okay, I would say. So nothing special at the end. So let's call the init. So what's up? What's going on here? So, okay, now the storage is initialized at the end. And you see the memory consumption is a little bit higher than normal because all the lazy references are in. So and now we could try to find a specific person. Find person by mail. Let's try this one. So let's say, let me just double check the body. Oh no, it's here the mail contains that that string. Let's see how long does it take to find that person. You see that? So we search through 600,000 rows, and it needs around 70 milliseconds to get the data. We could have a short look to another person. Let's choose this one, for example. Give it a try. Sorry. So now let's change this a little bit. So send, zack. You see 12 milliseconds searching within 600,000 rows of data. That's, in my opinion, that's an incredible performance. I would say, think about any relational database with that amount of performance, even if it's lazy loaded. So it's quite good. So, and that's why I would recommend a structure like this, especially when you need to have, millions of data. But it's totally up to you, and it is up to your data structure. You can make your own decisions how to handle the data. And you see, even when we call for a specific row, the memory doesn't increase that much. You see that? It stays on quite low. So this is I would say this is a great opportunity to store big data, even when we have an in-memory database. Okay, a lot of jumping around between windows and thing, but I think it's quite interesting to see how lazy loading basically works and how to handle that. And I try to give you an idea how to handle an in-memory database instead of a normal relational one. It's a little bit different, but it is working great. There is another point I want to mention is some customer or some people on the booth, for example, on conferences, always ask for, what about 4 or 5 terabytes of data? How to handle that within EclipseStore? I would say, in my opinion, the best solution would be, first you have to make a definition what type of data is inside your current database. So, and then you have to make the decision to say, okay, there are, let's say 50% of the storage is based on binary data, images, documents, whatever else. So this type of data should not stay within your database. So because this is data which is not needed in the database, there are quite better solutions like AWS S3, binary storages, whatever. Store it there, much easier to handle. And one important thing is, if you store it on an S3 bucket, for example, you will be able to address it directly. So the traffic of that binary doesn't go through your application server. It goes directly to your front end maybe. And this is a big advantage. So use an S3 bucket or a binary storage instead of storing this to your database. That's the first point. And the second point is on the 50% left data, how much data is or should be archived data. Most of you carrying the data all the time within the database. And when we ask for what is the really important data, let's say we only need the last 5 years of the data. Sometimes all the people have or customers have the last 20 or 30 years of data within their databases. Try to find a good way to move data every night, for example, to archive, and that prevents your database from scaling all the time and makes data much more cheaper than the. And now the left 20% data, this is exactly the data which is made for in-memory handling for EclipseStore, for example. And this is up to you, then using EclipseStore for exactly this 20% data. All the other data could stay on the relational database or on S3 bucket, whatever. And that is, I think that's the thing behind. You should find the right storage technology for the right type of data. That's what I recommend you. Okay. One question, is it allowed to have data classes with private final fields? Yes, of course, it is. You could do whatever you want. All Java functionality is supported by EclipseStore. even Lombok, records, whatever. So every Java functionality is supported by EclipseStore. Okay, so any questions regarding lazy loading? So we are good in time, I would say. There are only two topics left, and I promise you I keep it short. The first topic, which is available, is legacy type mapping. That could be interesting to you. Of course, I created a project. Let me share this. It's not really necessary to share that because it's just I would call it an exercise or demonstration, whatever. But sometimes it makes sense that you have that. Okay, so legacy type mapping. I also prepared a small presentation for that. So I'm well prepared. So okay, here we are. Okay, legacy type mapping. Or what if I have to change my data definition classes? So that was a big issue when we started to create EclipseStore. There was always the question, okay, what happened if something on my data model changes? And it took us a lot of effort to find a proper solution on that. But for now, we are good with the solution as it is. But first, we have to clarify how the storage works in a way. So I explained that a little bit before. Each entry, I would say, each entry of the storage, of the binary part of the storage, consists of two informations. The first information is the object ID that identifies the specific customer, for example. And there is another one, it's the type ID. This is what you could see here, the 166 here. And that defines the type of a customer. And with that information, we are able to calculate the range of a binary part of the binary file to identify this one is a customer. And this, and this is how it basically works. So as I said, a type ID and an object ID. So now when we change something, by the way, there are some data types which are supported within Java, within our documentation, not that important. So what happened when we change a customer? So changing something within EclipseStore works like kind of like a versioning. In that specific case, we have one customer, which is the old one with an ID, last name, first name, mail, and gender. And we created another one, which has an additional field in it. It's called IP address. And what happened when we start up the application is EclipseStore recognized that change at startup and sees, oh, there is a new field within that class. And it creates automatically another object type ID. And that's it. So that means there is a new type, and that's it. EclipseStore doesn't care about that. It says, okay, there is a new type. I'm fine with that. Let's see what happened at the end. So, and now what now happens is whenever you touch an old customer without the IP address field, EclipseStore transferred the old customer to the new one. And this is how it basically works. That means during the time, you will have old ones within your storage, which stays untouched. That's okay. You don't want to transfer. You don't have to transfer it. And there are some news within. And this is the versioning works. It transfers the data when you touch it. And this is how the legacy type mapping works, basically. So this is the basic functionality, I would say. Okay. So the question is, what could be handled in an automatic way and what should be handled manually? And that question is, I would say, the same question like I have to ask when we talk about relational databases. What changes in a relational databases could be handled automatically by the database itself, and which one has to be done manually? I would say that's exactly the same discussion. And so let's see what could be managed automatically. We could manage renaming. We could manage moving fields from different rows, adding some fields, removing fields. Yeah, that's all things that could be done automatically. That means there is a heuristic in the background, and when you start up the application and you made some changes at the end, you will see something like that. The heuristic checks, okay, based on field name, position, data type, and some other informations within the class. Okay, first name stays first name, nothing has changed, it's the same 100%. Name, based on the type and the name in it, it suggests that 75% it makes sense that name changes to last name, and so on. So the heuristic tries to find out what happened within your class, and if this is okay, you see that, you could say, yes, that's exactly what I want to do, and you will be fine with that. So this is the way. To be honest, this is I only use this functionality at the end because this is working really, really great and did a great job. You could try to make it not work in the way that is how to explain that. It's quite hard to make it fail, that it's not working, but we will see that. But of course, there is another possibility to, without using the heuristic, especially, let me just, yeah, that's not that important. I will skip that. Let's jump in directly to the type mapping. So, and I created a master here, LegacyTypeMapping. Oh, wait, there are some questions, right? So let me just check. How would we implement a feature like find similar books that requires to compare several fields of a book without retrieving all the books in the memory? Find similar books. To merge them, do you really want to find duplicates? Is that what you need to have? Similar means duplicate books, for example. I need a book and I need to find a similar book. Okay, so yeah, you have to iterate through all the books to find a specific a similar one. Yeah, of course. I think it's the same on a relational database. Let's imagine you have a table with 1 million books and you need to find similar ones. Then you have to go through all the books. It's the same what a database needs to do in the background, except there is a specific index, for example. So when we're talking about hash map, for example, then you will be able to put the most important fields into the key, and that gives you the possibility to search with a better functionality within the key, for example. But if you use a list or a set, maybe, yeah, then you have to iterate through, or you stream through all the books. But you could use the parallel stream, whatever. All the functionality is okay. Especially when we talk about to find duplicates, for example, then use a set and create a unique key, for example, or you create a combined hash for that that helps you to find duplicate entries. all the Java functionality which is provided by Java to you could be used within EclipseStore. Maybe that helps a little bit. So what if you want to delete some fields from an old class? Yeah, just remove it. So it's exactly just remove it, but you have to be careful because after starting up the storage, the data is gone at the end. So that means when you touch it, EclipseStore will delete the old field within the class. So let's give it a try. So this is the master branch of the LegacyTypeMapping, and there is one domain object which is called author, and the author consists of two string fields: a male, first name, last name. That's all we need, just to give you an idea how this works. Let's delete the data. So we don't need the data anymore. So let's start up and create one element. So run as Java application. So let me just check which is the name. Okay, authors create. So localhost 8080 authors / create. Okay, authors create. It's created successfully. Let's see, there should be one author now within the storage. You see that? It's c.link at example.com, Charlotte, link. Okay. So let's stop the application. Now let's do some changes on the author. And for that, we move to the next branch. So the storage stays the same. So when we say refresh here, you see there is the data folder, which contains the data. And now let's move to the next branch. Switch to stage 1. When we now have a look to the author, you see there are some changes, or just one change. It's male author now. First name and last name is changed. So let's start the application. And now you will see exactly what I shown you within the presentation. Also, we need to initialize it. So refresh. And now this is exactly what you see at the end. The whole heuristic says, okay, male seems to be male author because of the position within the class, because of the data type itself, 70%. And I agree with that. That's okay. And it's the same on last name. And let's type yes by say that's okay. And now the application starts up and you see it changes directly. This is how it is working. So there is you might say, okay, that works basically, but what if there are some more complicated cases? How to handle stuff like changing from a string to integer, for example. What about this? So it's the same question. I could ask the same question on a relational database. How do you manage changing from string to integer, for example? Or vice versa. So it doesn't matter. So the point is, it's the same. In a way, it's the same way complicated like on other databases. But I would recommend, and we do it this way, that we create an additional field, and on startup on the application, we transfer the data to the new field. There is also some of our customers doing that in the way they're using the get and set methods. So that means when you call the get method of the old field, for example, it will be automatically transferred to the new field within some specific business logic to migrate the data. But then you have to have all that business logic all the time within your project, and I don't like that. So for now, we're doing that the way that we download the storage from a customer, for example, we update it, and after that we uploaded the data again. This is how we used it. yeah, there are many more examples, and especially there is also a manual way doing that, and I want to share this with you. It's a huge topic, I would say, which is called, yeah, as I said, legacy type mapping. All that stuff is explained, and there is also an explicit mapping. That means if there is a case which is that complicated that you need an explicit mapping, then you have to do it this way. And just to give you an idea how this is working, you need a file which is called refactoring CSV. And this enables you to create your own mapping, saying, okay, this is the old contact to the new contact. And this is the class itself. This is the first part is the class. The second part is the field name. And that gives you the possibility to create your own mapping, I would say, to ensure that you do not need the heuristic at the end. But to be honest, I never used this explicit mapping before because of, yeah, I would say one important or two reasons. The first one is the most changes are made during the development. I would never recommend to using the legacy type mapping during the development. Create proper mockup classes for development and delete the storage all the time, and then you don't have to deal with that. So that means use that legacy type mapping at the moment you're starting in production. Then it makes sense. And the point is, if the application runs in production, the changes are not that big anymore. So, and if they're, then you have to do it this way, saying, okay, I download the old storage, I'm doing some migration stuff and so on locally, and then I uploaded the storage with the new version at the end. So this is, yeah, an advice from my side. There are some other things you could do, but I think that's okay for now to do an explanation. I think the point is handling the data is mostly, or changing the data or legacy type mapping is happen in a great way behind the scenes. You don't have to care about it. When it's based on smaller changes, or I would also recommend doing changing step by step, not doing all the changes like here. This one is moved, this one is renamed, this one is new. Do it step by step. That improves the way that the heuristic works well. So, and that's what I would recommend at the end. Yeah, okay. Any question? One is here. After changing the fields, do we have to perform a complete transfer? No, you don't have to. So that's exactly the point why we invented a versioning like this, because changing everything. I mean, you could do that by loading all the objects and storing them. Then you have transferred it completely. That's totally up to you. You don't have to do that. It's managed in the background. So you don't have to take care about that. That happens automatically, yes. The only advantage I would see is when you do it once, you transfer all the data to the new format. That gives you the advantage that you were able to delete the old type from the type dictionary. So you know what I mean? So when we when we go to the data, you see the type dictionary, and especially this one, this is what I want to explain you. You see that? This is the changes we made on the author class. You see that? This is the old data type author. And remember, we changed male to male author. This is the new one. And when you transfer all at once, and you would be able to delete this entry here. But yeah, who cares? Better not touching that persistent type dictionary at the end. Okay, so that's the legacy type mapping. There are a lot more to explain about legacy type mapping, but I would say if you really need it, have a look to the documentation. There are a lot of help. If there are some further questions, feel free to contact us to help you with best practices and so on. That's okay. Okay, so there is one topic left. If there are no further questions regarding legacy type mapping, so then we could switch to the backup, and then we are good to go. So backup strategies. There are two backup strategies that is provided by EclipseStore out of the box. I will do that directly within the storage, within the documentation. Give me just a second to find the right topic. Here we are. Configuration backup. Here we are. So as you can see here, there are two different backup strategies that we provide. And the first one, we call it the continuous backup. I always call it, it's kind of like a mirror, writing a mirror somewhere on every insert, let's say, or any update. Automatically a mirror will be written in the background, and this is one way to having a basic backup, a continuous backup. This is quite easy to set up. Just use the builder pattern as we already talked about, and just add a .set backup directory somewhere, and yeah, you're good to go. In our projects with our customer, mostly we do the mirror on a second persistent volume. So we mount one persistent volume for the main storage and the second one for the mirror. And on top of that, we use the full backup functionality, which is also provided out of the box from EclipseStore. It's just one line of code. But it's quite important to use that full backup out of EclipseStore itself, because you never know. So I knew that there is some functionality like clone or something like that to clone a persistent volume within Kubernetes and so on. Please do not use this without having kind of like a listener within your application. I'm not pretty sure if there is a listener to prevent your application, or to say, okay, whenever someone calls the clone method on a persistent volume, you have to take care about that the Eclipse storage, the storage manager is shutting down. Then you will be able to clone the persistent volume, and then you start up the storage manager again. That could be possible. But this is up to you. I would not recommend doing this. I would suggest to use the full backup out of EclipseStore itself, because then it's part of the thread itself, and it's a full backup to write the data somewhere. And in our case, we use the full backup mostly. We write the data to S3 bucket, for example. That means the first step is creating a mirror on a second persistent volume and a full backup on an S3 bucket at the end. And whenever something happens, when the storage crashes, whatever, just copy the whole file directly back and start the application again, and you are good to go. Let me share the project with you, as always. Backup strategies. Oh, I already shared it, right? So doesn't matter. So let's do it again. So that's the project itself. So I will also jump into my project here. Let's see which is a good. Yeah, let's start if the within the branch continuous backup done. And as I explained, this is not really a big deal to set up the continuous backup. Yeah, in that case, we use the MicroStream XML file. I already told you that. And here you see there is a backup directory string, and you could use this property to create, to add the path to your second persistent volume, for example. to create the mirror there. It's, by the way, writing the mirror is a separated task. It's not a blocking task. At the end, it's happened in the background. So that means writing that mirror does not decrease your performance by writing the data at the end. On the other hand, when we talk about, let's just jump into the car exercise, we initialized it here, and you could also say dot set backup directory. There are two methods. The one is for set backup directory in user home, and one is set up backup directory somewhere, and just add the path to the second persistent volume, whatever. So this is all you have to do to create a backup like this. You have already seen that when we talked about the configuration. Let's see if it's still available. Yeah, you see that here. And yeah, this is the backup directory. And you see we have that 4 channels at the end and the persistent type dictionary. And when we now open the backup directory, you see it's the same. So it's an exact copy of the already existing storage. Okay, what next? The full backup is the next step. So let's move to the next branch. Full backup done. Yeah, don't close all, don't save. Full backup. It's also just a small string, sorry, a small line of code. Let me just jump into the task. That's it. We normally use the Quartz scheduler. I'm pretty sure you are familiar with the Quartz scheduling framework. And most of the time we use it to create those full backup once a week, once a night, whatever. And it's totally up to you to handle all the backup files at the end. Normally we be doing things like keeping the last seven backups, and if another one comes, then we delete the oldest one. This is how we used it normally. This is not an embedded functionality. The functionality in EclipseStore is only creating the backup itself, the files itself, and you have to deal with when to delete older ones and so on. This is up to you. So as I said, it's not really a big deal handling those backups. There is one thing I have to mention is you should not use the backup functionality for replicating stuff. Some of our customer has the idea to use the backup directory as a replication for some other application. This is not, you should not do that. So this is forbidden, I would say. So this will destroy your backup at the end. Okay, so continuous backup versus full backup. And let's see what questions you have. Can you perform the backup at remote servers or cloud? Oh, hold on, something went wrong. Can you perform the backup at remote servers or cloud persistence? Okay. I hope I understand it. So mostly, yeah, we sometimes we have that that possibility. Then we create some REST endpoints, and within that REST endpoints there is the code to create a full backup at any time. So especially when, okay, let's say we need to do an update, and before the update or before shutting down the system, we need to create a new full backup, for example, then we use some REST endpoints to doing that. It's not an embed functionality of EclipseStore. We use REST endpoints instead. Okay, with SQL databases, we can use query-like, which guess does not retrieve all the data in memory. How would we do the same thing with EclipseStore? I think it's quite difficult to compare a normal SQL database to EclipseStore. I think you always have to consider that when we're talking about relational databases, we see that that memory thing is people always said to me, okay, understand how EclipseStore is working, but is it really necessary to have all the data within the RAM? Does it RAM is expensive and so on? And they told me stuff like this, but they forget that you will need RAM on the database itself anyway, and you will need RAM on your application server also. And when we're talking about using a technology like EclipseStore instead of using a relational database, we were able to put both systems together, and we could double the amount of RAM for users. Because when we talk about querying, you always have to take care about that your database itself has enough RAM to handle all those queries on the database side without sending the result back to you. So, and RAM on your database, it's insane expensive, much more expensive than the RAM you will need on your application server side. And I think that's quite hard to compare both together. I knew there is functionality like query-like, but this is what happened on the database side. And I'm pretty sure there are functionality within the streams to find similar ones, especially with some framework support, maybe with Apache Lucene or stuff like that. But data, you have to load the data to compare it. So, or you need a specific index or stuff like that. So let's compare an object which consists of 100 fields, for example, and you will only need the first 10 important fields to compare it. Or it's quite hard to say. It depends on the business logic and your needs, and try to find out a good solution. Maybe yeah, but I'm pretty sure there's a. I'm not able to share the GigaMap functionality so far. I'm not allowed to do that, but I'm pretty sure that this GigaMap could help you finding similar things, because there are some functionality embedded to achieve that. But for now, you have to deal with the regular Java components and so on. I hope that helps a little bit. Okay, so let me jump to the topics just to ensure that we talked about everything and I did not forget something. We talked about proper lazy loading. We did some research on lazy loading and how does it works and so on. We talked about LegacyTypeMapping, some handling class changes and so on. There is another interesting point I want to say is when we talk about the data types that you are allowed to use within EclipseStore. I already mentioned that you could use any Java related type within your classes. It's totally up to you. But I would say do not use third-party classes within your storage. You should not do this because maybe during the time there are some changes within that classes on that third-party library, for example, and this will lead to problems at the end. So storing Java native stuff, it's okay, but please do not add some third-party stuff to EclipseStore at the end. Okay, and last but not least, we talk about backups. Not that big issue creating backups on that. And yeah, based on that, now it's time for question and answers. I'm done with all the topics I want to share with you. It's up to you. So are there any further questions so far? Or some recommendations on your side to improve the training, whatever, let me know. That's a good point. Yes. It's EclipseStore is a framework. So that's exactly the point. So that means we are not able to access the same data storage from 2 Java runtimes. So that's yeah how it is. I would not say this is on purpose, because there are some technical restrictions that we have to deal with. But in the past, we as a developer and project manager, we always recommend not accessing one data source from different applications, because that leads to some different business logic and so on. And we always recommend providing data via REST to multiple different consumers and so on. And on EclipseStore, it's the same. If you want to consume the data with different applications, just create a data provider application with Micronaut, with Spring, whatever, and share the data via REST. That makes definitely more sense. It keeps your traffic smaller, because all that, let's say, horrible Hibernate stuff and lazy and eager management, whatever, it's hell on earth, I would say. I love Hibernate and I love relational database much, and I worked a lot with it, but it has some problems in it, especially when database is growing more and more. And I would recommend doing REST makes totally more sense than any other solution. And there is another point I would recommend. Whenever you could think about splitting your database into parts or modules that make sense for standing alone, kind of like a sharding. That means there is one data provider for customer, one data provider for orders, for example, one data provider for companies, whatever. It's just an idea. That makes data much more scalable at the end. And there is another big advantage. If company is not available because of the pod is restarting, whatever, you will have access to the customers at the end. So that makes the reliability on your system, that improves the reliability on your system much more. It's just an idea, and we did that in the past. So we tried to find proper modules, and yeah, that's a good way to keeping a database more scalability and more reliability at the end. I would not call it microservices. This is a different topic, but finding good modules makes really sense. And EclipseStore gives you the ability to, let's say, using EclipseStore for customers, using a relational database for archive, find the right technologies for your needs. And I'm pretty sure you will be at the end much more cheaper than using a big monolithic database for all the data. This is not the way how it works nowadays. So, okay, but this is a discussion for another evening, I would say. Of course, you could. So after that, give us some days. We need to cut the recordings, but you will get it as a YouTube link at the end, a private YouTube link, and then I could have a look on this. Okay. Yes, that brings me to an end. I have to say thank you for joining the training. Hope this was interesting for you. I hope you learned a lot. If there are anything to improve, let me know. Just send me an email. Let me share my email address with you. c.at microstream.one. So this is my email address. Feel free to contact me if there are any questions. I hope you enjoyed the training, and I wish you a nice evening and a good week. Yeah, hopefully we see each other together on the Advanced 2 training. Thank you very much. I'm still here for a bit, so if there are questions, let me know.